Last time we saw the anatomy of a cross-site request forgery attack, or CSRF for short. We saw how it worked, and what sort of consequences one could expect from such an attack. It's challenging to pull one off, but it could be pretty bad. And it's also really hard to detect since it's the legitimate user who actually ends up performing the action. In this episode, we'll see how to protect against this attack vector. In addition to not putting destructive actions behind GET requests, there's a pretty simple fix for CSRF attacks. The gist of our protection strategy is twofold. First, we're going to be grown-ups about our apps and not put destructive actions behind GET requests. And two, destructive requests are going to get a token that only our actual servers will know. Forms originating from elsewhere will not know it, and so we can check all destructive requests against this token. Let's have a look at a module that helps us do this. We're going to use the CSURF module. First things first, let's install it, npm install --save CSURF. With that installed, we drop it into config application.js. Near the top of the file, just under where we require express, we put in var CSURF equals require CSURF. And then down in our middleware section, after we require cookie session, app.app.use CSURF and call the function that it returns. Notice that we didn't need to use any of the options that CSURF makes available, but let's have a quick look at what we could have done. When we use CSURF, we can supply an optional object whose properties change its behavior a bit. The first is value, and it's very instructive in how our protection works. By default, CSURF will check each incoming request in 4 places for our token. It will look for an _CSRF property in our query string and in our request body, as well as checking for a couple of headers in our request. If these values didn't cut it for us, we could pass in a function for value that looks elsewhere. Maybe you want to use a field other than _CSRF because you were using that name for something else. I don't know. For node/, this default works. Next, if we wanted the server to retain this token value in a cookie instead of wherever we store our session, we could do that by passing in a truthy value for the property cookie. We're storing our sessions in a cookie, so this may be confusing. So remember that we could have done something like a Redis backed session store. The default works for node/, so again, we don't change this. The last option is a way to ignore checking the value on certain types of requests. This is a performance optimization. By default, we're going to ignore the token on GET, HEAD, and options requests, which is just fine because we're grown-ups who take our work seriously, and we're not putting destructive requests behind those verbs. Now it's a sad day for totallylegitforum.com, because watch what happens now. We go to hit that sweet form button and... error, invalid CSRF token. Look at that. We didn't erroneously transfer funds, and that's great. We do have 2 problems though. First, this error page isn't exactly a stellar user experience, and 2, none of our existing forms are going to work because we're not transmitting a CSRF token back to our server. Let's fix that error page. To do so, we just drop in a nice middleware. Let's open a new file at app middlewares invalid CSRF token.js. First, we lay down our error handling middleware skeleton, where we just do function, the name of the function. And remember that error handling middlewares have an arity of 4. And then, of course, we export the function that we declared here. And then, ripping this straight off from the docs page, CSURF will inject an ebad CSRF token into the middleware chain. And we only want this middleware to handle the error if that's what we're looking at. Other errors belong to other handlers. And then we need to handle it appropriately. Normally, I am all for trolling people who try to attack a site, for example, redirecting them to Rick Astley's Classic of Yesteryear. But in this case, the one viewing the page is actually our victim. So we just present a little message. We'd want to make this page look a bit nicer and probably have appropriate links to logging back in and resetting the session and so forth. But we opt for the classic cop-out and leave that as an exercise for the viewer. And then we hook it up in our error middleware section of the file in config application.js. Now let's fix our forms. If you recall what CSURF is looking for, we want to get our token into our forms. We have a few forms, so I won't show doing that for all of them. Looking at one will give us an idea for how it's done. Right now, if I try to sign up for the site, watch what happens. Exactly what we expect. In the CSURF docs, we can see that it adds a function called CSRF token to our request objects. This function gets us the value of our CSRF token. We just need to chain it through to our route handlers. Let's open up the route handler file that serves our form at approutes auth_user_routes.js. We only need the token when we're laying down our form, so it's tempting to just put this directly into our render calls like right here. But what if a form submission contains a user error? We'll end up re-rendering it even on post and puts. To keep things simple, we'll do a quick middleware. Open a new file at app middlewares attach CSRF token.js. Let's lay down our standard middleware skeleton, function name. This one only has an arity of 3 because it's not an error handler. And module.exports equals attach CSRF token. Now we flesh out the function with a simple one-liner. res.locals.csrf token function equals rec.csrf token. This should look familiar, but note that we're not calling the function here. We're just attaching the function and not its value. The variable name should give that away. Doing it this way, we're not incurring the cost of getting the token, but we can still use it everywhere. And then of course, we want to make sure that we don't hang our server, so we need to call next. Now we just hook this up in config application.js. We'll drop it in right after attach authentication status. With that in place, open app views auth users new.jade. We just need to drop this token value into our form now, with an input of type hidden, whose name is _CSRF, and whose value we interpolate as actually calling the function. We don't actually want it to show up, so we use a hidden field. We name it _CSRF because that is what the middleware expects. If your value option to the middleware defines a function that looks for something else, you'd use that other name here. That would be a good candidate to put into some configuration variable that you would attach to your views, but since we don't break from the default, I don't bother with that here. Lastly, note that we are calling that function here. We need to invoke it to get the value. Now when we reload the page, we can see that the hidden field is in place. And now when we sign up, the form goes through. We'll need to go through and do this to all of our forms, as well as remember to lay it down with new forms going forward, but that's something I'll do for node/offline. We've protected our app from one possible attack vector. Hooray for us! Seriously though, the solution here is so easy that there are fewer than 0 excuses to not use it. That's right, if you don't use it, then you lose valid excuses to other potentially unrelated issues just to maintain cosmic balance. I hope that these last 2 episodes have done more than just showed you copy this, paste this. We walked through how the attack actually works before showing how to mitigate it. Now when you're putting this protection in place, you'll know why, and hopefully it'll start turning the wheels for other application security issues. We all benefit from a safer internet. Until next time, happy coding.